Hi, I am Saraj Mudigonda at Imagination Technologies, and what we are going to demo is do some magic here with CPU-free WebRTC processing. I'll just go over the slides quickly, and you can see what I mean by that, and then followed by the demo. So, Imagination, as you know, Krishna just had a talk on a keynote, basically, on what all Imagination does. So as you know, we have graphics, we have video, we have MIPS processors, and we have flow cloud technology, and we have connectivity, Wi-Fi and Bluetooth, and over and above, what we have is WebRTC. And so the different devices I'm showing here, what this really is Imagination is already in everything, and we believe that WebRTC will be in all of these devices. As you can see, it's mobile, like we have the graphics GPU, then all the consumer and mobile multimedia, we have our video hardware IP, VP8 and H.264, H.265, VP9 and all of that. And of course, the networking and variables, well, we have all the MIPS processors. And so it's just not talk. We go by numbers, and these are these are already the devices that are deployed across. And so we are in 7 billion products that are already shipped today, and that is 3.5 million per day. Now, coming to the reality, the WebRTC world, what are we demoing here? So this is what we are demoing. We are demonstrating the power, quality, platform diversity, and user experience. So it's all native web clients, mobile web clients for the WebRTC. Power, to talk about power, the CPU-centric processing is all the traditional way, where we have the voice processing, video processing, and video pre-processing and post-processing. Everything is done in a CPU. But what we are doing is we are offloading all of that to reduce power consumption. And what we do is only the voice processing is done in CPU. The rest of the video and everything is done. The video pre-processing, post-processing, everything is CPU free. That is, we do the pixel processing. We leverage the hardware accelerators for the video, and we also have the GPU compute for all the video pre-processing and post-processing. And I'll show you what I mean by that in a little bit. The next is quality. I'm sure you have seen this slide multiple times. I might have showed it earlier, but these are some of the issues that we have, that we solve, which are device-related, network-related, and packet losses. So if you don't mitigate these, then what happens is you have dropped calls and a bad voice quality. The platform diversity, we are on different devices. As you can see, we have from surveillance cameras, which is WebRTC enabled. We have our friends sitting over here, Quanta, who basically were kind enough to share their hardware platform. And what we have is a WebRTC-enabled camera now. So this is not two-way video conferencing, but it is a one-way video streaming. And of course, we are on smartphones and tablets and the home gateways. And it's all on Android and iOS. Basically, the same technology is across the different platforms. The user experience, the demos speaks for themselves. Basically, what we have here is, let me switch to the demo quickly over here. So what I'm showing here is a video conference call on a mobile device. Now, what it really does is it basically takes it dynamically adapts to the bandwidth, as you have seen, there's a lot of Wi-Fi issues over here. And what we do is we mitigate. You have a good video and voice quality. On top of that, as I said, we do the GPU compute features. So this is, what you're seeing. I'm not sure, it's in purple there. So there are a bunch of options that we have provided. And all of this is happening in GPU. It's not a CPU, there's nothing basically going on CPU. CPU is free, and all the processing is being done on GPU. I have the same rule. I have just increased the brightness and saturation. There are a bunch of parameters that are there, which I can play with. And then it can basically increase the user experience on the remote site. The other thing that we have is the camera application, which I'm going to go into a little bit. But before that, I have a few other algorithms that we have, like face detection and all the algorithms that Krishna showed sometime back in his keynote. We have implemented some of them. And we encourage the developers basically to contribute, and they can implement many more features. For example, this is one of the features where we have a negative picture, and here this was how I used to look 20 years back. This is in black and white, or 40 years back when I was not born. So this is, you can do all of this. The graphic, compute in the GPU compute. Quickly to move on to the next demo that I have here. This is the home surveillance camera. This is an IP camera that we have from Quanta here. And what it has is it has a MIPS processor in that, and it has a VP8 and as well as H.264 hardware accelerators. So we support both of these. That is, we support MIPS, ARM, and x86, all the platforms, and we take, as I said, we take advantage of the hardware accelerators that are available on the platform. So to show you the simple demo here, so as you can see, the demo, moving the camera here, and this is, you can say, a single video call. So all of that WebRTC stuff is ported on this camera on a MIPS platform integrated with VP8 hardware accelerators, encode, decode, and it has H.264 as well. So this can do, if you have the bandwidth. Again, we have all the bandwidth adaptive algorithms implemented on this. If you have a good bandwidth, it can do 720p or 1080p, and and then it'll adapt based on the bandwidth availability. It basically goes to lower resolution. So this is WebRTC enabled. That's it. So this is all about the presentation. Sorry, this was the slide I wanted to show you on the EP processing. This is what is going on. So if you see here, the camera has a MIPS processor in there, and the Quanta's own VP8 hardware and the hardware encode and decode, as well as H.264. It supports both. So we in our WebRTC support both of those, and we can talk to the the mobile clients as I demoed just now. Thank you.